In this video, we are going to learn about geometric sequences. So identifying what they are and how to come up with different kinds of formulas to represent them. So you'll notice here at the top of the page, there are 8 different sequences, and it says in the instructions that 5 out of them, 8 of them, are geometric. So what I want you to do is to think about the patterns, what's going on with these numbers, and then see if you can figure out what it means for something to be geometric and pick out the ones you think are geometric. So I'm going to ask you at this moment to pause the video, see if you can figure out of the 8 which ones have something in common that would make them be geometric. Okay, hopefully you actually paused the video and gave it a try. So I'm going to take a look at what I came up with. We're going to zoom in a little bit here. So in the first 4, what I did was look at the patterns. So for the first one here, we're multiplying by 2. In this one, we are subtracting 20. This one, we're multiplying by 3. This one, we're multiplying by 2. If I slide across. This one, we're multiplying by 1.5. We're adding 2.5 here. We are dividing by 2 here. And we're adding 10, then 20, then 30, then 40. So all of them have patterns, but only 5 of them are what we would consider to be geometric. So I want to look for things that are very similar, and I noticed that I have 1, 2, 3, 4 that involve multiplying, 1 that's dividing, I have 1 subtraction, 1 addition, and then this rather unusual pattern here. Now, we learned yesterday that when you add and subtract by the same number every time, that's something called arithmetic. So this one here and that one there are both arithmetic, which means that the multiplying ones are going to have to be my geometrics. Now, dividing as well are also considered to be geometric. So an arithmetic sequence was one where you're adding or subtracting the same number each time, something called a common difference. A geometric sequence is one where you are multiplying or dividing by the same number every time, and that's not called a common difference. That one's actually called a common ratio. So a geometric sequence is a sequence where you find the next term by multiplying by a common ratio. So I am just going to fill that in. I'm actually going to say multiplying by the same number. And I'm going to write underneath that that's the common ratio. Now you are going to notice I did not put dividing, because when we divide, we're going to accomplish that by multiplying by a fraction instead of actually using a division sign. So I did just write multiplying, but it does also encompass dividing because we can do that using fractions and decimals. So we are going to take a look and see if we can come up with some formulas for a geometric sequence. So here it says we want to write a recursive formula and an explicit formula for the following sequence. So we're actually going to do 2 formulas. A recursive formula we've talked about before is a formula where you use the previous term, the term that came before it, to find the next term. And an explicit formula is one where you're looking at using the term number. So if I want to find number 5, I'd use the 5 to find the next term. So I have the sequence 5, 10, 20, 40, and 80, and I am just going to zoom in again. So first thing you should always do is see if you can figure out the pattern. So am I adding, subtracting, multiplying, dividing, what's going on between these terms here? So if I looked at adding and subtracting first, to get from 10, take away 5, means I would have added 5 here. And then to get from 10 to 20, if you do 20 take away 10, you'll notice that we added 10. So I don't think this is arithmetic because I'm not adding by the same number every time. I can then try doing the opposite, dividing here. So to get from 5 to 10, an easy way to check is to take the second number and divide it by the first. So 10 divided by 5, we multiplied by 2. If I do 20 divided by 10, we multiplied by 2. 40 divided by 20, we multiplied by 2. And 80 divided by 40, we multiplied by 2. So this is geometric because I am multiplying by what we call a common ratio, and the common ratio here would be 2 because that's the number that we're multiplying by every time. So to figure out a recursive formula, that's how we're going to start. Those are the ones that we're most familiar with. I'm going to start by just listing my terms, and I'm going to call them term 1, term 2, term 3, term 4, and term 5. Now we followed a very similar process when we did this for the arithmetic sequences. We're going to do something very similar for the geometric. So I'm just going to list that term 1 is 5, term 2 is 10, term 3 is 20, term 4 is 40, and term 5 is 80. And then we're going to look at what did we do to get our next term in the pattern here. So the first term, that 5, I don't actually know where that 5 came from. So actually right now, I have no idea. It's just a 5. I don't know where that came from. That was just the first place. That's where the sequence starts. It's the first term. I don't have any way of calculating that. But the second one, I can get that 10 by taking the term before it, which is 5, and multiplying it by 2. I can get this 20 by taking the term before it, or 10, and multiplying it by 2. I got this 40 by taking 20 and multiplying it by 2. And I got this 80 by taking the 40 and multiplying it by 2. So to figure out my recursive formula, we're going to do one more step here. This 5 is really term 1. So instead of putting the 5, I'm actually going to put term 1. So this is 5, I'm going to use the bracket, times 2. Oops, I wasn't supposed to do that. I was supposed to write term 1 times 2. Sorry about that. Now 10 is really term 2. So I'm going to say this is term 2 times 2. 20 is really term 3 times 2. And 40 is actually term 4 times 2. So this is where we have to think a little bit about the pattern that we're seeing, and we want to try to figure out a formula for what we call the nth term, or term n, so just some other random term in our sequence. So I notice here that on all of these we are multiplying by 2. I'm actually going to put that in the front because it looks a little bit nicer. Now term 1, term 2, term 3, term 4, I notice when I look at them, this is term 5, this is term 4, this is term 4, this is term 3. I notice that every time this term is one smaller than the one I'm looking for. So if I'm doing term 5, I use term 4. If I was doing term 6, I would use one smaller, which is term 5. So here we're not looking for term n, we're doing the term that came before it, so one less, which is term n minus 1. So you can find term n by doing 2 times term n minus 1, and that works for term 5, 4, 3, and 2, but it does not work for term 1, so I have to add in what term 1 equals as part of the formula, since it does not follow the formula. So my recursive formula is Tn equals 2, oh, you can't see where I wrote that in, times Tn minus 1, where T1 equals 5. Now, from here, I want to try to find the explicit formula. So I'm going to take what we've already started and just continue on and do some different things here to find my explicit formula. Now, term 1, I'm going to swap it back out and say term 1 was 5. So this is 5 times 2. Now here, 10 or term 2 is really what I just wrote down, 5 times 2. So instead of putting term 2 here, I'm going to do 5 times 2, and then this is times 2. Okay, for the next one, for term 3 times 2, term 3 is this one, which is 5 times 2 times 2. So I'm going to put in a replacement for term 3, and then I'm going to multiply it by 2. So I'm going to put in term 3, which is 5 times 2 times 2. And then the last one, same thing, term 4. We're going to take term 4 times 2. Now term 4 is really 5 times 2 times 2 times 2. That's a lot of 2's. Now I find that's a lot of 2's to be writing down. So what we're going to do is see if we can find a shorter way to write this. Now I know this is 5. I've got 1, 2, 3, 4 2's. So 2 times 2 times 2 times 2 is actually the same thing as 2 to the power of 4. You multiply by itself 4 times. Okay, this one here has 1, 2, 3 2's. So 2 times 2 times 2 is going to be 5 times 2 to the power of 3, since there are 3 of them. Here we're doing 5 times 2 to the power of 2 because there are 2 of them. And this one here is 5 times 2 technically to the power of 1 because there's only 1 2 there. And if we come all the way back up to that original term, term 1, which was 5, it is going to be 5 times no 2's, so 2 to the 0 because there were absolutely no 2's. So to get my explicit formula for term n, I notice all of these start with the number 5. I notice they all have a base of 2. The only thing that's different on each one is the exponent. So I might have to zoom out to see this whole thing here. I see for term 5 we used 4. For term 4 we used 3. Term 3 we used 2. So we're always using a number that is 1 less. So what's 1 less than n? N minus 1. That's going to be 1 less. So I don't have to multiply anything out. This is as good as it gets. This is going to be my explicit formula. And we do from here want to see if we can come up with a shortcut like we did for the arithmetic. And I believe on your sheet this does say geometric. It's a typo on mine. We want to come up with a general explicit formula for a geometric sequence. So we want to come up with a formula for Tn. Now if I take a look at that 5, where did that 5 come from in the question? That 5 was the first term. So I'm going to write the first term, and I am going to write this out in words first. So it's the first term times, now this 2. The 2 is what I am multiplying or dividing by each time, and that is called a common ratio. So it's the common ratio, and that's to the power of n minus 1. So you notice my brackets are a little different just to group the words together, but the order is the same. So we want to use the letters that match what's in the textbook. For the first term, that's the same as what we did with the arithmetic. The first term in an arithmetic sequence is called A. So here we're also going to call it A. That's exactly the same. Now in the arithmetic formula for common difference, we use D. So for common ratio, we actually use R. And then to the power of n minus 1. Once again, you'll notice I just grouped it a little differently with the brackets, but it all means the exact same thing. So T is for the term, the nth term, equals A, the first term, times R, the common ratio, what you're multiplying by, to the power of n. So which term you're looking for. If I'm looking for term 10, I put a 10 in there, minus 1. So in the next video, we're going to do a couple of examples.